So I think it's about that time. I'd just like to welcome everyone to our webinar on 5G front haul validation with EXFO. And it looks like we're going to get started. So my name is Steve Case. I'm the moderator today, and I've been with ElectroRent for almost 9 years now. And today we have with us Kevin Perez. Good morning, Kevin, or good afternoon.
Yes, good morning, sir. Sorry about that. Kept missing my mute button there.
There you go. Yeah, Kevin's been with EXFO for probably double that I've been with ElectroRent. So you've been out there for a while, and we thank you for holding for this for us today. And just before we get started, I have a little bit of some housekeeping that we want to do here. We are going to have a little commercial, so we'll get into that. About ElectroRent, we're a large test and measurement equipment company with actually resources and warehouses all across the world. And fortunately for all of us here on the EXFO webinar today, we have EXFO equipment all around the world in the US, in California, in the UK, near London, in Asia, and actually we have a small office in Canada too. And sometimes equipment ends up there. But for rentals, primarily, we got you covered, and that's our little commercial for us today. And continuing on, we will have questions and answers, and that's in our webinar section. If you do have a question, go ahead and put it in there, and then we'll stop in different areas when we need to and get all your questions answered. And with that, Kevin, I am going to pass it over to you for the presentation. So hang on a second.
Good deal.
And there we go. We're in the presentation.
Perfect. So hopefully my face pops up here in a second.
There you go. I see you.
There I am. So good deal. So thank you very much for that. Again, my name is Kevin Perez. I am a senior apps engineer with EXFO. So I've been with EXFO for about 18 years. Before that, I started in excavation, way back in '91, placing fiber and all of that. So there's been a lot of changes in the industry, through that period, right? And so one of the big ones really is just the innovations that we've seen with front haul, with basically your cell phones and all these, these fancy devices that we have today, and the amount of bandwidth around that, right? We're still putting cable on the ground. We're just putting a lot more cable on the ground, is really the oversimplification of that, right? And so we will get into that and talk about some of the different technologies that's driving that, and then some of the innovations behind that, right? So some of the innovations behind that. So we'll talk a little bit about the front haul. So a little front haul network overview, just a high level thing, right? Because we have about 45 minutes here, with about 10 or 15 minutes of questions here at the end. And so we're just going to cover just highlights of it, right? And then we'll get into fiber link validation. So what you need to do to kind of qualify and verify the fiber that you're placing on the ground from a front haul perspective. And then we'll kind of close it up with protocol testing. So CPRI, eCPRI, timing validation, those types of things we'll cover as well. And so, so to get into that, we'll start with really the promise of 5G. So what 5G is bringing us today, right? There's a term that you'll be seeing more and more if you haven't seen it yet. This URLLC. We love acronyms in the telecom world, right? So it's really ultra reliable, low latency communications. And really where it really plays, where it plays is really with like automation in vehicles and stuff like that. So we're seeing more driverless cars and those types of things, or intelligence between, different vehicles. And so it's critically important to maintain that very reliable, low latency. So very short delay, because as these vehicles are moving, they need to be communicating very, very fast, right? And exchanging data. And so really validating the front haul for this, and also qualifying it for the newer bandwidths, and qualifying it for that kind of stuff is critically important, right? And so down here at the bottom, we have these three little items here. What we're looking at for 5G is we're really reducing or decreasing the latency as much as possible, right? So that delay. But we also need to increase the reliability. So we're trying to improve the quality of the signal, improve the bandwidth, so scale the bandwidth more, but we need it to be ultra reliable, right? And so that's why front haul validation becomes very, very important. And so it's important to understand that, right? And we have a lot of aging fiber out there today that we're retasking for a lot of this new technologies. And so things like, existing pinches in the fiber, high reflection connectors on old panels, those types of things need to be qualified and verified from an aging plant perspective. But of course, we're rolling out a ton of new fiber, right? I'm working with one customer now that's doing 2,000 route miles a month of high count 864 and 1728 fiber, all in preparation for a lot of it's 5G, but really it's high speed data to the customer, right? And so now we're starting to seeing shifts in the technology. So a lot of the technology that we saw on the on the backbone side, which is where I spent a lot of my career, right? Working city to city, country to country, those types of things, those high bandwidth backbone cables, we're using technologies like ROADMs and DWDM and all these advanced optics. Now we're seeing all of this being used on the front haul side, and so we'll talk a little bit about that. And so some of the complexities around some of that as well. Because when you look at a front haul network today, this is kind of what we're looking at here, right? It's a mix of different types of deployments, feeding different places across your network, right? And so you can look at this and, from a centralized location, you're feeding all your bandwidth out of your CRAN, out of your office, wherever this location is at. And so you might have your BBUs here, so your baseband units, so this is basically the translator that converts your bandwidth into the protocol that's necessary to communicate with your mobile devices, right? So we're starting to see these being centralized now, where in the past, they were sitting at the base of that tower, right? The base of the antenna. Of course, we still have a lot of this. We still have a lot of these, this type of infrastructure. So traditionally, this right here was the backbone, or I'm sorry, the front haul. From the baseband unit to your remote, so to your RRU, that's traditionally your front haul. But now all of a sudden, our front haul is being pushed further and further away to these BBU hotels for these centralized baseband units that are being placed. And of course, at the same time, you have a lot of different types of deployments out here, right? And so, and one common denominator with all of this is all fed primarily by fiber today, right? So if you think about it, and this is a quote years ago from the CTO of Verizon Wireless, I believe it was, that said a large portion of wireless is wired, right? And so this is the fiber part of the validation, is qualifying all of this fiber infrastructure. And as we push the front haul further and further out, those cell techs or those installation techs that just lived and breathed here, all of a sudden are going to be spending more time over here, right? And now they have 20 kilometers of fiber that they have to maintain. And so this is kind of the mix of stuff that we're seeing within the network today, going across that. And so some of those, technologies that I talked about that were primarily on the backbone or in a metro core environment are now being used for a lot of the front haul communications. And today we're talking about front haul, but this could be, running DWDM to enterprise customers, just raw Ethernet or something like that, right? Because if you think about it, it's just all Ethernet until it gets converted into CPRI or VDSL or, some kind of QAM signal or DOCSIS signal or something like that, right? But if you look at these, these spans now, again, they're quite a bit longer than they used to be. So now we're dealing with, again, up to about 20 kilometers is what we see on the high end for distance. So you have this centralized CRAN over here where the BBU hotel's at. So now we have all these baseband units that are sitting up to 20 kilometers away from your remote. And so now this is all front haul. And so how do we maximize this, right? We don't want to run one fiber to every single cell tower. That's a lot of fibers. I mean, we're placing a lot of fiber in the ground now, but it just doesn't make a lot of sense. So that's when we start muxing our signals, right? Muxing our signals is basically, a prism is a mux demux. In fact, let me switch over here to my whiteboard because I like to show this. So this is a whiteboard that I have that I just have a bunch of graphics on it anytime I segue into something, right? And so essentially, this is a prism, right? And hopefully you recognize this graphic. This is I like to call it the dark side of the moon technology. But essentially, what's happening with muxing of light or combining the signals? If you think about it, a rainbow is just demux sunlight. And so, you know, you have the sunlight coming in, hits the atmosphere. As it interacts with water vapors in the atmosphere, it starts to refract and reflect, and it causes basically a rainbow. So you have this white light coming in, the sunlight in this particular case, and as it hits the prism, each wavelength kind of reflects in a different direction, right? This is muxing and demuxing of light. So over here, we have all of these wavelengths in here, because these are wavelengths, right? Red is essentially, you know, for most of us, for VFLs, is around 640 to 680 nanometers, right? Blue is roughly, you know, 480 nanometers, or in that range. So these are wavelengths. They're just visible wavelengths. The wavelengths that we deal with in DWDM are up here. We can't see them. They're still demux, but they're up here somewhere, right? You know, so you have, you know, infrared, ultraviolet, you know, that type of stuff. But this is where we have our wavelengths that we care about. You know, this is where your 1550 lies, and your, you know, and those wavelengths, the C band, the L band, and those things, they're up here. We just can't see them, right? So this is a mux demux. So instead of running one fiber to one site to every single radio, we essentially run a fiber all the way, you know, to the antenna, and then break up into individual wavelengths. So now we're dealing with individual wavelengths that we need to qualify, because they get demuxed at the site, and one wavelength will go to, say, a 5G radio, and then another wavelength will go to a 4G radio. And so now you have issues with validating and mismatching transceivers, which we'll talk about as well during the validation part. And so this is from a very high level what DWDM is. I don't want to get too much deeper than that, honestly. And so that's, you know, that's basically what, you know, what we're looking at and what we're talking about when it comes to that, you know, when it comes to that. So let me get back to my slide here. There we go. And so that's what's happening here. And so with this, we have some challenges, of course, right? We have some challenges from a fiber perspective, and we have some challenges from a protocol perspective as well. And so now we're dealing with technologies that we haven't dealt with in the past, right over here. So we're dealing with technologies we haven't dealt with, you know, in the past. And, you know, some of these technologies are going to be things like, say, DWDM, which we just talked about. So understanding there's multiple wavelengths now, so you have to have certain types of meters that measure channelized power. So a standard power meter won't work. And of course, you know, we're dealing with longer lengths, so we talked about that as well, you know, and emerging technologies. We're having higher bandwidth, so we're having more issues with things like optical return loss, which is noise on the fiber, which we need to qualify during fiber characterization. From a protocols perspective, you know, we also have issues here, right? Now we're dealing with, you know, pushing the signal further and having technicians that have to do, you know, testing for CPRI or eCPRI, right? Timing needs to be, you know, looked at very closely. You know, validating the transceivers. So all these, you know, SFPs and those transceivers that are out there, you know, before you probably had a 1310 transceiver, right? That was the most common wavelength being used. It was 1310 down, 1310 up, you know, transmit, receive. Now we're dealing with bidirectional fibers. Now we're dealing with individualized transceivers that have to match on both ends, right? 1555.57 or some other ITU channel. And so, you know, so we're starting to deal with stuff like that as well, right? And so it's important to understand all of that stuff's coming into place. And from a front haul perspective, you know, as we get closer and closer to the site, you know, obviously we need to start validating more and more. And this is where we start to see the transition of responsibility for, you know, for some of these circuits across the network. And what I mean by responsibility is, again, you're closer to the actual location itself. So, you know, to the site itself. So the BBU, is it here at the bottom, you know, at the base of the tower, or is it 20 kilometers away, right? And traditionally, you know, now we're starting to see the centralized CRANs where the baseband unit is further away. So what that means to us is that we are transmitting, you know, a CPRI protocol all the way down the fiber here, right? So that means we need to validate CPRI from way over here. But we also still need to validate the fiber, right? Because you traditionally have a connector down here somewhere, you know, at the base of the hybrid cable here. And then the hybrid cable goes up, and then you'll have some sort of a connection here. Now, there are some newer technologies where it's all kind of a home run, where it's just kind of plug and play. But traditionally, this is what you see here. Then, of course, you'll have individual fibers, that break off of this OVP or this hybrid connection up here into individual radials. And each one of these individual radials, again, will need its own transceiver, right? Its own SFP if it's running DWDM. And so there's a lot of things that we need to validate on this side as well, from the front haul perspective here. So that's really critically important to understand, right? And so what does that mean to us? So how do we qualify our fiber? How do we qualify the protocols and that type of stuff? And so, we've been training on a three-step validation process for quite some time here. So a lot of folks that are cell techs or installers, anybody who's doing maintenance on front haul systems, this is something that you're probably doing today or will be doing here in the future. And so, of course, we have some sort of a fiber validation. So fiber connection issues. I can't stress the importance of ensuring that you have clean connectors, right? I can't stress this enough, because when you look at these networks here, when you look at these networks, you're going to have multiple connectors in there, right? You're going to have multiple connectors. And so if you're feeding this circuit out of this centralized location, right, you're going to have this fiber coming down the path. And then from here, it might be individual fibers to each one of these towers, depending on, how you're deploying this. You could be using, again, something like DWDM technology here. So, you're muxing and demuxing signals. So now instead of, these particular channels, the way they are, you might have something like DWDM here, right? Where you're doing individual channels or wavelengths to each location, however it is. But if you think about it from a connector perspective, you're going to have a connector, multiple connectors inside of here. So you might have, a connector to the outside plant. You might have them in the tie cable. So you'd have connectors there. You might have a connector here. You might have a connector here. And of course, one here and one here, right? And so you have multiple connectors to the system. So connectors really are important to understand. They're critically important to understand because they're the single greatest contributor to noise in a system. So if you look at a connector, if you look at a connector, so this is, this is supposed to be a piece of fiber here. So when we inject light into the fiber, it bounces off the cladding. This is essentially how the signal works, right? Anywhere where there's an air gap in the fiber or a change in material, a connector, you're going to have reflection. This is light that comes back towards a transmitter. So we have two critical parameters that we care about when it comes to connectors. One is going to be loss, and the other one's going to be reflection. Loss is pretty easy. Power in, power out. How much power am I losing going across that connector, across that splice? That is issue number one. And so that's easy to understand. You take a power meter, you read light levels, it'll tell you, hey, I have minus 15 dBm of light. That's my power, right? Reflection is something different. Reflection is basically what contributes the most to noise. It's the quality of the signal. This is the amount of light that reflects back, is reflection. And typically for, say, a blue connector, a UPC, we expect about a minus 50 dB or better. And for APCs, it's well into the 60s and higher, typically, because it has an angle. And so the angle gives it a different type of reflection. So it actually performs better. So if you disregard the negative, the higher the number, the better, right? So I want a 60, I want a 70 and those types of values. But this is reflection. This is what contributes to noise. This is what increases, or what degrades your optical signal noise ratio. So this is the amount of signal that you have compared to the noise floor. And connectors are the single greatest contributor of that. So on the Ethernet side of things, this is what, and depending on the type of transport you have, this is what affects your bit error rate. That's one of the big principal causes of bit error rate is from OSNR, which is directly impacted by ORL. And ORL is span reflection. And to oversimplify it, it's span reflection. So it's critically important to understand connectors. So when you look at a connector, so if I have a unit here, so if I have a unit here, like this FTB1 here, in fact, let me go ahead and kill this Ethernet platform here. And so if I were to look at a connector, and this is part of the front haul validation, so I'll kind of show you from a high level what it looks like. And so an OTDR basically is a device we use to kind of map out our fiber. It tells us the length of fiber, the location of splices, if there's a backhoe sticking up out of the cable, those types of things, right? So I'm just going to do a quick test I'll do a quick auto test here, or not auto test. I'll do a quick 5-second test here. And so I have a different seminar on how to set OTDRs up. That's its own seminar by itself. What I want to show you here is what a connector looks like. And so I basically have a bunch of fiber in my office here, daisy chained with launch cables and a network simulator at the end. And so anywhere we see a spike on an OTDR or IOLM, this is reflection. So if we look right here, we can see, right here at 1,000 feet, we have 0.2 dB of loss, almost 0.3, and neg 55 dB reflection. This right here is a UPC connector. Right below it is actually an APC connector. So you can see how much better APC connectors perform. UPC, APC, UPC. And so this tells me that this is a low loss connector with good reflection. So I don't have to do anything here. Now, if I had one that had high reflection, right? So if I had one that had high reflection here, had a tall, had a big tall peak here, then I'd have to go address that. Inspect that fiber, clean it, reconnect it, test it again, see what the reflection looks like. And it only takes one connector, because this is noise, right? It only takes one connector to impact noise for the entire span. And so I like to equate power or loss with water pressure, right? You can have good water pressure, but if the water doesn't taste good, then you have bad quality, right? And so that's kind of the difference between the two. So ORL is more the quality, where attenuation and loss is kind of the power, right? That's kind of the power of it. And so it is important to understand that it is important to inspect and clean your connectors. So having some sort of fiber inspection probe that allows you to look at the end face is really, really important. And then of course, from a fiber perspective, from a fiber, link perspective, that's where we use something like IOLM or the OTDR. And then we'll follow up with a CPRI test, which we'll talk about here in a bit. We're starting to talk about a fourth step now more and more. 5G, it's the big promise of 5G, not just bandwidth, because honestly, bandwidth is not that difficult. We increase bandwidth, we give you more bandwidth, right? Obviously, there's a lot of logistics behind it and cost, but from a technology perspective, it's bandwidth. What's difficult is reducing latency, right? Because you have a length of fibers, you have the speed of light within the glass, and then you're flying through the air, then you have processing time with equipment and all that kind of stuff, right? 5G reduces it, right? We're looking at, 1 microsecond or less of latency when we're talking about, 5G. So now we are starting to look at qualifying timing. It becomes critically important. And so that's something that we're looking at and doing quite a bit more. And from a front haul perspective, if you're not doing it today, you will be doing it very, very soon, right? You will be doing it very, very soon. And so back to fiber characterization. Again, it's fiber inspection and fiber link characterization. And so what are the main contributors? Basically it's dirty connectors, is the main reason why we inspect connectors. And we're starting to deal with more and more different types of connectors. You have these OptiTips, which is these, multi-fiber hardened connectors. I'm not sure why I put a graphic of electrical tape over here, but I did. And so, yeah, I don't know what this has to do with dirty connectors, but hey, there you go. So, a large part of existing network issues is dirty connectors. So we talked about that, the importance of inspecting those connectors and making sure that they're of the highest quality and improving the reflection on those. So you visibly inspect it and clean it if necessary. And again, an OTDR can help you qualify those things, right? And this is not just for front haul, it's anywhere. Connector inspection it's critically important everywhere else. And then that leads us to the OTDR. So we inspect and clean all those different connectors throughout the network, right? At the CRAN, at the hub, at the MUX, at the radio. I mean, there's connectors everywhere. So just visualize where there's connectors. You need to inspect those and clean them if necessary. OTDRs will help you identify if there's, it'll help identify if there's a break in the fiber, if there's a pinch in the fiber, the performance of your splices and your connectors, right? So this is a good way to qualify the system. And IOLM is probably one of the biggest tools that we use for that, to qualify these networks here. But basically, an OTDR will tell you the length of fiber. It'll give you the overall span reflection, ORL, as well as connector reflection, splice loss, connector losses, and those types of things. So it'll qualify that you have all that plugged in. And in fact, oops, didn't mean to go that. So if you go back to the OTDR here, so from an OTDR perspective, this is what we see here, right? We see the length, and that's what we see, going across the horizontal here plane. This is the length here. And then this is the amount of power. And so we can see all the individual, reflections. And then we have some splices in here as well, right? And in the event table, this will tell us or give us an indication of what we're looking at. So at the end of my launch cable, this is actually an APC connector here. It's a really clean APC connector. And then at 500 feet, I have another connector. And then, a little bit further away, only about 81 feet or so, I have another event. So you can kind of see how it kind of maps it out, right? But what's really important to understand is the difference between 1310 and 1550. And so if I were to shoot this in real time with an OTDR, shoot this in real time, and this is, getting into a little bit of troubleshooting here. If I were to pinch the fiber, let me see if I get, if I pinch the fiber, you can see where it just starts to drop down, right? That's from pinching the individual fiber here. If I were to test this at both wavelengths, so I'm going to test it at 1310 and 1550 without the pinch. So let me go ahead and test both of these wavelengths real quick. Go through there. And so this helps us validate, again, link validation. So, we're looking for problems. And honestly, we see a lot of pinches, usually in slack loops, right around the radio, anywhere you're managing slack, whether it's in a handhold or on the side of a radio or, an antenna or something. So if you look at event number 6 here, it's about 0.1 dB of loss at 1550, and then 1310 is going to be, right around the same. But if I were to pinch this fiber, so I'm going to go in here and pinch this fiber. I'm going to change a setting here that you normally wouldn't change, just because I'm going to pinch it pretty good. Let me let it do that. So I have the fiber pinched. I'm going to retest it with that pinch in there. And then at 1550, you should see a significant drop. So you see that big drop right there? And so that's essentially where my pinch is at. And then at 1310, we still see some significant loss, but it's not as impactful, right? So if I look at 1550, we went from 0.1 or whatever it was to 5.5 dB of loss. If we go to 1310, we're going to have 1.4, which is, pretty decent, but it may not be network impacting where 5 could be. And so the reason why I bring this up is because a lot of the legacy front haul systems that we have today, the old 3G and 4G stuff, is traditionally 2 fiber 1310. So 1310 down, 1310 up, right? That's traditionally what we see. And as you transition to these newer radios and 5G and newer technology like DWDM, you're getting into the C-band, your 1550 stuff, right? And now all of a sudden, that same fiber that's been on that structure for however many years is going to have 5.5 dB of additional attenuation, right? And so now that needs to be resolved. So that's part of the validation. Again, earlier we talked about you're placing a lot of new fiber, but there's still a lot of old stuff out there as well. And there's, you're not going to place new fiber when you already have, infrastructure out there. And so that's something that, that OTDRs will do for you. And of course, there's newer tools now like IOLM. And IOLM is Intelligent Optical Link Mapper. It's something that EXFO came up with. It does multiple acquisitions at multiple wavelengths and multiple pulses, right? And so it's designed to really give you the most comprehensive information from the fiber with not as much expertise involved, because a lot of us today are doing a lot of different things, right? So I do a lot of the optical training, but I also do a lot of the spectral training and the CPRI training and the Ethernet training and the 400 and 100 gig training. So I'm constantly like retooling and retasking and relearning, right? And so that's one of the intentions of seminars like this that Electro-RAN and us provided, is to give this education out there, right? But a lot of technicians today are doing stuff like the new eCPRI and the CPRI and, all of a sudden 5G and, and PIM and all of the drive testing and all this stuff that you're doing. It's a lot of different technologies, and the technology, as we introduce more, you still have to maintain the old stuff, while learning the new stuff. And so IOLM kind of helps with that, right? Because it allows us to put the intelligence into the actual hardware and software. And so, we have a lot of custom configurations for front haul and those types of things. And in this case here, what I'll do is I'll grab that fiber again. I'm going to pick it up off the ground here. I'm going to pinch it again, and then I'll let it run. So you notice there's no distance, time, pulse width. I'm just going to, I got this one called fast, medium, range. So it does a fast test up to, I think 20 kilometers or something like that. So I got to pinch in the fiber, and I'm just going to let it run its thing. And then it's going to go on there and just analyze the fiber for me. And return the results. So basically, ILM is kind of an advanced OTDR, again, to oversimplify things. But now you have icons, and then you can start seeing some information up there. So you see that little indication of a pinch. And that pinch I put right at a connector. So there's the connector, and then here's a pinch. And it'll say down here, inspect the fiber in this area for excessive bending or cable compression, because I put a pinch in the fiber right here. And so this, that's some of the importance of understanding what, from a front haul validation part, what an OTDR does, right? So I'm more of a hands-on kind of a person. And obviously I draw a lot, but I think it's important to understand what we're doing from a high level. We have seminars and stuff like that. We have them recorded. EXFO OTDR, and you'll probably find a video of me talking about advanced OTDR theory and IOLM. So if you want to get deeper into that type of technology, we have a lot of content out there for that as well. Or you just contact us directly and we can talk to you. And so that, was basically fiber characterization from a very high level. And again, fiber inspection, and then looking at the actual fiber itself with an OTDR or IOLM. And there's other things like power measurements, checking light levels, and those types of things from a fiber characterization perspective as well. But those are the two big ones that we talk about the most. This leads us into the protocol validation. So validating the fiber, you're looking at the front haul, you're looking at the physical layer of the glass, right? But there's a signal that travels across that. And so with a lot of the different technologies, and depending where you're at within the network, the technology shifts and changes. So from a mid-haul and backbone perspective, this is essentially what we see here. We see a lot of Ethernet, we see a lot of transport technology like OTN, 400 gig, high-speed stuff. So this is between, CRAN. This is between offices and cities and states, right? That's the backbone technology. Once you start getting into the mid-haul would vary, right? Right now, a lot of the mid-haul that we're talking about today is basically within the CRAN. Traditionally, mid-haul was kind of like your backhaul to the front haul, right? So now this is the mid-haul. So of course, there's still a lot of this. So a lot of those old towers and structures that still have the VBU on site, which is still a lot of the stuff that we deploy today, that's going to be fed by Ethernet. That's going to be fed by Ethernet. And so, when I talked about it earlier with the whiteboard that I had, so let me pop up my whiteboard here. So when I talked about it earlier with the whiteboard here, there was a graphic that I kind of skipped over a little bit, and it's over here. So I like to use this one quite a bit. And so to kind of emphasize what I'm talking about and the difference between these different locations. So again, this is basically our centralized location here, right? This is our CRAN. In this example, this is a CRAN. And so coming out of here, you're going to have fiber that deploys all across the city, right? You're going to have fiber to this mobile site. You're going to have fiber to the DSLAM. You're going to have fiber to the remote PHY. So depending on the type of technology, if you think about it, most everything's fed by Ethernet today. There's still a lot of OC192s and, T3s and those types of things, but to a very large degree, most of this is Ethernet, right? Unless the BBU is over here. If the baseband unit's over here, then it converts it. But if you think about it, most of the technology that we have, it's Ethernet that feeds a router or a BBU. If it's a BBU on site, then it becomes CPRI, or OBSI, or whatever technology you're using to communicate with your mobile device. It's Ethernet all the way to the DSLAM, then it's something like VDSL. So it's just converting. It's Ethernet over here, then it's going to be something like DOCSIS, right? Depending on the technology you're using. So basically, we're just taking our bandwidth, pushing it over Ethernet, and then converting it somewhere. And in our case, it's converting it at the BBU, right? So Ethernet is feeding the bandwidth. So that's what we're feeding. And we're doing it over DWDM. We're doing higher speeds. There was a day when it was a T1 that fed a mobile site, right? Then all of a sudden it was bonded T1s. And then it became OC3s and OC12s and those types of technologies. And now it's Ethernet 1 gig or 100 megs. Now it's 10 gigs, even 100 gigs feeding some of these locations because of the bandwidth requirements, right? And so so that's what we're talking about when we're talking about all these different technologies, because there's a lot of different technologies out there. And so from our perspective on the front haul, this is what we're dealing with over here. It's over here on the left, right? So we're looking at these different types of technologies that are feeding your cell sites. CPRI, OBSI, eCPRI, and then of course, the technology is changing, and then whatever bandwidth is feeding that. And so this is the front haul protocol validation portion, right? And so The first thing you need to do when you look at this, though, is you need to validate your transceiver. So there's a lot of different transceivers out there. It could be a bi-die transceiver, which is bidirectional on one fiber. It could be 1310, it could be multi-mode, it could be DWDM, whatever it happens to be. It is critically important that you make sure you validate your transceivers. And so within our unit, so this is the FTB1. So this unit here is the FTB1 with an 88260 in it. So 88260 is our multi-service module. So as you can see, it'll do a lot of things. It'll do SONET, Ethernet, OTN, CPRI, OBSI, eCPRI. It's a beast. And it'll also do the timing testing. So 1588 and SYNC as well. Everything's in one, right? And this also has the OTDR in it. So and I'll show a graphic of it later. But we have a tool in here called iOptics. So essentially, I have a 100 gig transceiver and a CPRI transceiver on this unit. And so with the iOptics, so you'll see here, I have an SFP28, which has a multi-rate CPRI transceiver. So this will do, rate, it'll do up to 9.8 gigs on this particular one, right? So the first thing I can do is I can go down here to where it says more, and this will tell me what my transceiver is. It'll give me the part number and all the speeds that it supports and the type of protocol. So this one will do CPRI, OBSI, LTE, this is what it supports here. And so what this allows you to do here is you can set some thresholds, and essentially this goes in and validates the transceiver's good. So you plug a transceiver in, you put it in loopback, you test to make sure it's good. We're looking at power consumption, which is a huge thing. You want to make sure it's not using too much power. And then there'll be thermal over time. So depending on how long you run it, how long did I have? I probably had it running for, let me see here, 1 minute on the BERT. We won't let it run for the entire minute, but you get the idea. It goes in there and it validates the interface. So it looks at the pinouts, right? To make sure that there's a good connection, to make sure that it's communicating. Then it runs in there and it does, it measures its own optical power. How much power am I transmitting and how much am I receiving? And so you'll kind of see what that. So it's coming out at, neg 1.7 dBm. And what is it arriving at? And then once it's done doing all of that stuff, then it'll run a bit error test for 1 minute to see if there's any errors on it. And once you have it fully validated, then you'll be able to plug it in. And of course, over here in the more section, we'll be able to validate that we do have the right wavelength and all that kind of stuff, right? So transceiver mismatch has always been a huge issue, and it's become a bigger and bigger issue with the deployment of DWDM ITU channels to the individual radios now. And so this is what this test allows you to do, to go there and validate it. Because that's the first thing you need to do, is to validate those transceivers first to make sure that they are the right ones. Because you don't want to go back up into that tower. You don't want to go back up into that small cell, do another truck roll because of an invalid transceiver. So it's always good to validate that first. So once you have the transceiver validated, then we can start looking at the link validation. So CPRI link validation, those types of things, right? And so on the same unit, we can run a test. So I'm not going to generate a report here, but we can switch it over to something like a CPRI test over here. And so this is a CPRI link validation. And what's interesting is I actually like to use this for validating, whether or not there's a communication or to a site. In fact, I did this, I started doing it once. I was in Houston working a small cell deployment, just kind of consulting with a customer. And what they had there at these small cells, and we'll just call it, and it was ironically, they were on, on transmission lines is what they were, right? So we had fiber coming out of the CRAN to these individual, poles here, and on top of these individual poles, they had these small cells all over the city, right? And so some of these are 20,000 feet out or more, and we were sitting over here testing over here. And so one of the big common issues that we have with small cells and with radio deployments in general is losing power to the unit, right? A lot of the newer ones will log the time and then move on, but the older ones didn't. They would just go dark. You shoot an OTDR test or an IOLM, and and you'd get this trace, that shows you, that it made it to this location. But is it broken, or did it make it just to this location? Is it dying there? What's going on? So what I end up doing is using CPRI link validation. And so with CPRI link validation, it'll communicate with the individual radio and loop the signal back. What does this tell me? If I get the signal loop back, I have power, right? I have power. I can check my power levels. Is there a break? Nope, because I got good power. So I got link validation. So I know that it's not a fiber problem, or most likely not a fiber problem. If I do have a problem here, it's something else, right? It might be more of a network issue or something like that, or an issue with the customer equipment or whatever. But my unit's responding to me. So it's powered up, it's responded, it's looped back the signal. I have link validation. And so we're doing the same thing, but just to a individual radio, right? And so in this case here, essentially you go in there, you'll select your, whatever protocol you're using. And in this case here, I'm on the wrong transceiver. No, actually I'm good. So I go ahead and put that in there and then set it up. And, I don't have a loop on this, this particular one right now. Let me, let me see if I can get a loop to come up. But essentially what it does is, you go in there, so the CPRI link validator is kind of a BERT test. So it'll, you'll plug in, so you'll unplug the transceiver from the baseband unit, you'll plug it into the test set. And then emulate the baseband unit. So you'll go in here and emulate the baseband unit. Say, I am the BBU, and then you want to communicate with the remote. And so once this is set up and established, then it'll communicate, it'll generate that loop, and then you'll see a signal here with power levels. So it'll give you a power level if you had link, it'll give you a power level, and then it'll sync up to the unit itself. And you know what? Let me switch there because I'm actually on port B. I'm on the wrong port here. So here it should be here. So now once this switches over, hopefully I get link if I switch it over here. I forgot I was doing a different test earlier and didn't set it back. So anyway, so this does a CPRI link validation. It communicates with the far end. So now you see I have link here, right? So I have link. So I'm getting power back to my receive side of my transceiver. So I've unplugged from the baseband unit, plugged into my test set. I'm communicating with the radio here. And so essentially all I have to do is once I have that link established, I just pick a stress pattern and hit start. And if so once I go into here, what I'm looking for, I want to see if I have stuff coming back, and I do. This is CPRI link validation. I know that I have the right transceiver on the tower. I know that it's powered up, and I know that it's responding to me, which is a lot of great information, right? So that's part of the link validation here. And that's what's happening here with this test, right? Is this link validation. And so that's that portion of it. And again, we're doing a lot of this now from a centralized location, but of course you're going to be, doing this from if it's an 04G radio or whatever, it could be on site. And so that's what we have here for the link validation portion. And then to kind of seal it all off, we're talking about timing. And so this is from a very high level. We have some good seminars on this. But now we're starting to see a lot of timing testing on there now. So if there's a lot of folks here that are probably doing a lot of front haul testing today, and this is not something that you're seeing today, a lot as widely deployed, but this is something that's happening right now. So we are working with a lot of different operators out there. So your mobile network operators, we are working with them very closely on developing and creating MOPs for cell techs and contractors. So keep this in mind. If you have one of our existing EXFO units, let us know which one it is, and it might support it, right? So I have the 88260, which does the 1588 testing and those types of things, right? And so timing is becoming a huge issue. So if you hear the word 1588 or eSync, then they're talking about testing timing. And this is something that's happening today, right now. So it is in your interest to understand more about this, right? So I brought this up because this is becoming the fourth step of our testing, is the timing itself, right? It is the timing itself, and understanding that that's something that's happening today. And so again, if you hear the words, like I said, 1588, Sync-E, Wander, those types of things, this is what we need to do. And this helps us validate the clock. And we have the fastest solution in the industry right now, right? Because it takes hours for some of the timing synchronizations with the rubidium clocks and those types of things for it to settle, up to like 3 hours or so, right? So imagine being on site for 3 hours just waiting for the clock, just waiting for the GPS accuracy on timing to lock in. And so we can do it much faster than that, right? That's a solution that you'll be seeing more and more, is looking at timing and qualifying that as well. And the actual timing. So, we have a GNS, so we can do it in 20 minutes, right? Which is about 90% faster than what we've seen traditionally in the past. And it goes into our 88260 here. And so we have these modular modules in the module. And so you pop one module out and put another one in. And that's what I have here is an 88260. I just don't happen to have the timing module in there. But that's something that you'll be seeing more and more of, because that's a huge part of the ultra low latency, reliability. And so I forgot to change the title here. So basically, all the stuff that we talked about today is in what we call our 5G solution. So this is a compact unit. This is about the size of an iPad on the front here. So that gives you an idea what the size is. So you can do fiber inspection, do your fiber link validation, IOLM, OTDR, look at your transceivers, do your protocol link validation, as well as do RF spectrum. So, BBU emulation, looking for interference. So we have something called optical RF. And so we can, over the fiber, look at the RF signals if there's any PIM or interference issues like that. So it's kind of all in one unit. So it's very nice, ruggedized portable unit that has everything that you need in one solution there. And so to kind of seal this up and open up questions, just want to kind of do a quick summary here. So basically, we talked about fiber link validation, the importance of it, right? 5G is really driving a lot of this. And so the demand for bandwidth is just incredible, right? We're seeing a lot of, 10 gig is basically a trib now, right? We're seeing a lot of 100 gig cores feeding these the front haul system. We're seeing 400 gig now on the backbone side. There's 800 gig just right around the corner as well. That's going to be coming. What does that all mean? It means more bandwidth to the customer. We're starting to do more DWDM and advanced technologies. So things like channel checkers and spectrum analyzers for looking at optics and individual channel powers. Those types of things are becoming, more and more needed and prevalent within the mobile network side. From a protocol side, we're looking at new stuff like eCPRI, which is relatively new, and other technologies that are coming along, as well as, the importance of looking at timing more so than ever, again, for the ultra, reliable, low latency networks that we really care about. And so hopefully from a very high level, this gives you kind of an idea of what we're looking at from a front haul perspective. And, if you have any questions or need any support, of course, we're out there. My contact information, let me do something fancy here. So my contact information is here. And so Kevin Peters with EXFO. And I cover, basically the whole U.S. But, even if you're not in the U.S., get a hold of me and we'll get you somebody to talk to. And with that, I will hand it back over.
Hey, Kevin, we do have a question.
Oh, excellent.
Okay, so it's about the SFP validation. So when you're using the iOptics for the validation, does it matter what cable you use in the loopback?
It depends on the optic, right? For me, all I use is, I just use a loopback plug. I got a loopback plug here. You can get these, relatively inexpensively, or just use a jumper. All right, just use a jumper. So if it's a single mode SFP, you got to use single mode. If it's a multi-mode, use multi-mode, and that's really the only thing you have to be concerned about. You may have to use an attenuator. So when you look at these transceivers here, so this is a 100 gig transceiver. If you look at these transceivers, and in fact, even if you look at, let me stop this link validation test here. And so if you look at these transceivers, there's different kinds, right? There's short reach, long reach, those types of things. If you have like an extended reach or a high power output version, then you should use an attenuator. You should use an attenuator to make sure that you don't damage your transceivers. So
yeah, that's a good idea. So don't have any more questions, but I just, while we wait and see if anybody has any more, I wanted to mention that we do have handouts of today's webinar in the handout section, so people can go and grab that. Waiting for any other questions to come up. I don't see any, but
well, hopefully I was
pretty awesome.
I was clear. So
yeah, I did want to mention that I did attend the 1588 webinar that you guys had. Was really in depth and awesome. So I do recommend that. That was a really good explanation on the 1588 timing and PTP. That was very good. So if you haven't seen that and how it impacts, the TDD signals in 5G. So it's very important actually. So that was mention that.
yeah, great. Yeah, absolutely. In fact, everything that we talked about today, we go, we have seminars and series, or you can just contact us and we can work with you on setting something up as well. That go much more in depth, right? Obviously, I just kind of brushed a lot of it because we're covering a lot of topics here. So the entire purpose of the seminar is really for kind of the overall, understanding of some of the issues that we see with front haul. Obviously, it's not everything, but it's a lot of the things that we see from our perspective. But everything from the CPRI link validation to fiber inspection to understanding advanced optics and basic optics and fiber 101 and CPRI and all of that stuff. We have individual seminars or courses that we do for that really go much more in depth. So for some of you that want to learn some of the newer stuff, so if you've been doing interference hunting and fiber testing for years, you might be more concerned about the newer stuff and brushing up on that, understanding that, especially timing. I can't stress enough how much timing is going to be impacted and the importance of testing it. And we are working really, really closely with all the major mobile operators on the requirements for testing, right? Because we do have the test suite for it. So if you really want to understand timing, as was mentioned, we just recently did a big training initiative on that in seminars, and it's good stuff, and it's important to learn because you want to get ahead of the curve. And and these are the items that that we traditionally see on the rental side as well, right? As new and emerging technology comes out, you want to give it a try, or get some equipment in your hands. This is the kind of time and place to do that. So.
Okay, so one more question here. See if you can handle this one. How do you measure latency in a CRAN architecture?
So for us, we have the let me see if I get back to that slide here, and I'll show it to you here. So essentially, what we have is we have a GNS portable antenna here. And so this is what we have. And so so you have to have, of course, some sort of a timing source.
You're
right?
covering up the screen, Kevin.
Oh, oops, let me get my face off there. Sorry about that. There I am. Let me put myself over here. And so yeah, so we have a portable antenna that we use. So.
All right, I'm waiting for any more questions, but this was really informative. I like the hands-on aspects here that you give us. It's really awesome.
Yeah, yeah. Usually I draw on the slide more, but the program that runs it crashed in the middle there, so I didn't want to. So I went to the whiteboard more.
Not a problem. So I wanted to thank everybody for coming, and make sure you grab that handout if you're looking for that. And thank you, Kevin, and we'll close it out now, and hopefully we'll see you in another webinar.
Yeah, absolutely. I enjoyed it. And everybody, thank you very much for your time. We know how valuable it is, and have a good day.
All right, thanks.